Have you ever discovered something that makes you stop and think, where have you been all my life? And this often happens to me when I'm researching other topics. In this case, I was researching scene storage for an upcoming video, and I came across a piece of information completely out of context that made me stop and think. And what that was this thing called RawRepresentable. Now, you've all dealt with RawRepresentable when you work with Enums and RawValues. But in this video, let me show you something that will possibly open up some new ideas for you. We're going to be conforming a custom object type to RawRepresentable, and we'll see how it can greatly simplify and tighten up your code when using AppStorage or UserDefaults. I love getting your feedback, so tap the thumbs up button if you enjoyed this video and leave a comment below. Make sure you subscribe to the video and ring that bell to get notifications of new videos. And if you want to support my work, you can buy me a coffee. There is no starter project for this video, so you can simply start by creating a new Xcode project and create an iOS app. I've called mine RawRepresentable Demo, and I made sure that I chose SwiftUI interface with the language of Swift and no testing or storage. Now, there's nothing special at all about my app other than I've added an app icon and a launch screen, and you'll find that along with the completed source code for this video, and the link is in the description. So what is RawRepresentable? Well, in SwiftUI, RawRepresentable protocol allows a type to be represented by a raw value, and it's commonly used with enums to allow each case to have a specific raw value, like an integer or a string, or some other primitive type that conforms to the equitable protocol. The primary purpose of RawRepresentable is to create a bridge between a custom type and its raw representation. With enums, we get that automatically by specifying that the enum can be associated with a raw value, like that int or a string. So for example, let's create a new Swift file. And I'm going to call it skill level. And inside there, let's create an enum with the same name. And I'm going to give it 7 different cases. And these are just different skill levels. So for example, beginner, novice, intermediate, advanced, expert, master, and guru. Now, in order for this enum to conform to the RawRepresentable protocol, we're going to have to specify that it is associated with a particular type. And that could be, in this case, an int or a string. Now, if we specify int, then beginner will have a raw value assigned to it of 0, and novice 1, and so on. If we specify string, however, then the raw value will be the string describing the case, like beginner and novice, etc. So let's make it a string. Now, in the view that I'm going to be modifying, I'm going to create a settings form that will allow the user to choose from a picker where the choices are going to be one of those levels. And I'm going to store that choice in UserDefaults. So I'll need to make the enum identifiable and case iterable so that I can use a for each loop array on all of the different cases. Now, in order for it to be identifiable, we'll need an ID property. And it can just be self, which is of type self. So let's return now to our content view. Now I'm going to start by creating an AppStorage property wrapper and provide a key of skill level as a string and create a variable using the same name, skill level, that is our skill level type. And I'll just assign a default value, and I'm going to choose beginner. And then I'm going to replace the entire contents of the body with a navigation stack. And inside the navigation stack, I'm going to create a form. And I'll add content to the form in a second, but first I'm going to add a navigation title and use the string settings. So as the first element of that form, we'll create that picker I referred to. And we'll use the title key selection and content initializer. So for the title key, I'll use the string skill level. The selection will be bound to our skill level AppStorage property. And then I can hit enter on the content. And in here, I can use that for each loop on our skill level, all cases. And because it's identifiable, we'll not have to specify an ID, but it will give us a skill level iterator that we can use to create our choices for our picker. So for each choice, I'll create a text view using the skill level's raw value, but it's lowercase, so I'm going to apply a capitalize modifier to capitalize the choice. So it's time now to test it, and we'll test it in the simulator. So I can make sure I'm going to choose an iOS simulator. I'll choose an iPhone 16 Pro. And now let's run it. I'm going to make a choice for our skill level. And then to ensure that it gets saved to user defaults with that app storage, before you quit Xcode, exit to the home screen, and this will force a save for sure. Now if I quit and run again, you'll see that your choice has been persisted. So what has been stored? Well, the app storage available is a skill level enum type. It's not a string. But I can inspect the user defaults and take a look at how it was actually stored. And that's if we can locate it. Well, what we can do is we can attach an onAppear block to our navigation stack. And within here, we can print the location of user defaults. And to do that, we'll use a static URL library directory, and we'll append the path, providing the string preferences with a capital P. And if we want to be able to easily open that from within our console, I'll just specify the path. So let's test this once more and run again. Now we see that that path gets printed to the console. So I'm going to roll this up a little bit because I want to right click after selecting this text and select the services menu. And from within here, I'll select open. And then run the service when I get that dialog box. And what this will do is it will open the location where you will see that file, which is our user defaults file, and it's a property list, a plist. Well, you can open this directly in Xcode, and you'll see that there is a key, which is skill level, and the value is a string, which is the raw value of that enum that we chose. And you see that this is the case because the enum conformed to the RawRepresentable protocol, that the value is stored is the raw value. If we had specified that the enum was an int, it would have stored an int. Now there's no need to do any reverse mapping of the raw value to the enum when we want to display it, as it's all handled for us through that RawRepresentable protocol. Now, before I go on to show you the true power of RawRepresentable, let's create two more app storage properties for our form. Above the existing skill level, let's create another one with the key name, and we'll create a variable of the same name and just assign an empty string. And below that one, we're going to create another app storage with the key allows notifications. And I'll create a variable of the same name that is a Boolean type with a default value of false. And then in your form, above that picker, I'm going to create a text field where the title key will be the string name, and the text will be bound to that name variable. And let's specify a text field style to be rounded border. Next, below that, I'll add a toggle using the string allow notifications, and is on will be bound to our allows notifications app storage property. So let's test this once more. And I can make some changes, adding a name and toggling that toggle if I like. So let's find that plist file again, still in my Finder. And I'm going to open up, and I'll see that the name is stored as a string, and the allow notifications is a Boolean property, which is good. One more thing, though, that I think is worth mentioning. You may have noticed that my simulator has this red button that pops out when I hover over it. And this is because I have an app called RocketSim installed. And it's an invaluable tool created by Anton Vanderlee. Now, I'm only going to show you one very cool feature of RocketSim. If I display the floating window, I can choose Perform, and from there I can choose UserDefaults. And it will open up the UserDefaults into an editable window for me without having to go to that Services menu and go through that onAppear print statement. Now, if my app is running at the same time, you can see that I can update my app from the RocketSim UserDefaults too. Now, this is very cool. And like I said, this is the least that RocketSim can do. And Anton has lots of cool videos showing you its power. I'll leave a link in the description. And full disclaimer, that link is an affiliate link. I'd encourage you to check out that app's webpage for yourself and give it a test drive to see if you like it. So now that you have an idea that if your type conforms to RawRepresentable, then its raw value is what is stored in UserDefaults through AppStorage. Well, this can become particularly useful when we want to store more than just a primitive type like that string or Boolean or int, or a collection of supported types like dates or URLs. I want to be able to store an object of my own type. So long as that type is codable, I can create a JSON string representing the data, and then I can say that that type also conforms to RawRepresentable, and then use a JSON encoder and decoder to transform the data back and forth between a string and an instance of that object. So let me show you how. First, let's create a new file and call it app settings. Inside that file, create a struct with the same name. And then create 3 properties identical to those app storage properties that we did. So the first one will be name, and I'll assign an empty string. The second will be the Boolean allow notifications, initialized as false. And the third will be our skill level, which is a type skill level, and I'll initialize it as a beginner, just like I did with the app storage properties. But we'll also have to make this struct codable. Now I'm getting an error here because my skill level isn't codable. So I'm going to have to return to the skill level and make it codable as well. And that's not going to be a problem because it's a string. Well, now we'll need to make this type conform to the RawRepresentable protocol. So I'm going to create an extension for that. So the extension will be on app settings conforming to the RawRepresentable protocol. Now it's going to require 2 different things. First, we'll need to specify what the raw value is going to be. And in this case, it will be encoded strings representing the instance as a JSON string. So we can create a computed property for this. And that's what's going to get stored in our UserDefaults. So we'll use a guard statement to get the data by trying to use a JSON encoder to encode that object, which is self. And then while we're still in the guard statement, we can specify that the app settings is the string derived from the data using UTF-8 encoding. Now, in the case that it fails, we'll just return an empty JSON string. So that's just a string with these 2 parentheses. Otherwise, if the guard checks are successful, we can return the entire app settings string, which is our JSON string completely formed. So that is what we get saved to AppStorage. When we retrieve it, though, we'll need a failable initializer that will provide us with that raw value string, which is our JSON string. So then we can then use a guard check to get the data from that raw values string data, again using UTF-8. And then at the same time, we'll use that guard to get an instance of the app setting by trying to use this time a JSON decoder to decode from that data into the app settings self type. Now, if this fails, it's a failable initializer, we'll just return nil. If it was successful, however, we can specify that the instance itself will be that decoded app settings. Now, theoretically, this should be all we need to do, but apparently not. Turns out that, as I discovered in this article by Use Your Loaf, I'll leave a link in the description, that the debugger, it seems, repeatedly calls the raw value getter until it finally crashes with that error as you see here. The solution, however, as he discovered, is surprisingly easy. All we have to do is provide our own struct with our own coding keys implementation. So let's return to our app settings struct. Now, because it conforms to codable, typically I should just be able to start typing coding keys in the structure and Xcode will help me create them. But it fails to provide me with any auto-completion. And I struggled with this until I discovered that the issue here is that we've already created our RawRepresentable protocol conformance. So what I can do here is just temporarily comment this out. And now I can start to type coding keys and you'll see that we get that autocomplete. So let's let Xcode generate the keys. Well, that's not enough. We'll also need an initializer from the decoder. So again, let me let Xcode do that for me. I don't need to do anything else. And then finally, we'll also need the reverse, the encoder, which is a function. So again, I'm just going to let Xcode do that for me. So now it conforms and we've got our own coding keys. Now we're going to want to create an instance of this type. Since we have an initializer here that is from the decoder, we'll also have to provide an initializer so that we can use it in our view. And since we're providing default values for all the properties, we can just provide an empty init. Don't forget, though, to uncomment out that RawRepresentable extension. So let's return to the content view now, and we can comment all three of those app storage properties out and replace it with a single one. And I'm going to replace them with a single one. And this time I'll provide the key being app settings, and I'll create a variable of the same name that will simply be an instance of that new app settings struct, which now conforms to the RawRepresentable protocol. So our bindings now are not bound to those former app storage properties. They're bound to the properties of our app settings object. So let's test this out once more. But before we do that, we'll need to delete our old UserDefaults file because it has those old values in there and it would just be confusing. So let's run again and you'll see that our properties are all set to the default values. So let's enter some values in here. And then again, I'm going to exit to the home screen. Now you can open your copy of UserDefaults however you like. Let me start with using RocketSim. Now I see a single key, which is app settings, and it's a string, which is that JSON string provided as the raw value of our encoded object. And if you didn't have RocketSim, we can check by going to our Finder location and open that UserDefaults plist in Xcode, and we'll see that the key is app settings and the value is that JSON string. This is fantastic. The technique works not only for app storage, but also for scene storage. So in the next video I'm going to be covering scene storage and show you how you can use this for storing and restoring app state. Well, that's it for this video, and I hope you've learned something new that you can use in your projects going forward. If you've enjoyed this video, please give it a thumbs up and leave me a comment below. Make sure you subscribe to my channel and enable notifications so that you're made aware of new videos that I release. And you can also download my free channel listing app to be able to search for and find content from any one of my over 350 Swift and SwiftUI related videos.